All right, we're going to do a Riemann sum problem with this graph right over here. And the question is asking, find the area, an estimated area of this integral from 0 to 8, meaning from here all the way over here. But we're going to use Riemann sum with 4 subintervals with right endpoints. So whenever they say right endpoints, left endpoints, and midpoints, they're talking about using rectangles as opposed to trapezoids. Okay, the first thing we have to do is figure out our intervals. Okay, we want 4, so that means we want 4 rectangles. We want to fit them up nice and neat equally from left to right. The length is 8, so basically it's the length of the whole thing divided by how many intervals you want. So each x width has to be 2. Okay, so I'm going to go like this, 2, 2, 2, and I ran out of color. Okay, right here. Okay, so each will represent the width of one rectangle. Okay, so we're going to use the right endpoints of a rectangle. So at 2, notice the right endpoint will start right here and do that. For this one, the right endpoint will start up here and do this. And then for this one, it's kind of strange, but this one's going to go down because, again, you have to use the right side of your, or the right corner of your rectangle. So the right corner is going to hit this one. So it'll be like this, or let me use a different color. Okay. And then this one will be right here. So what do we have? So we have this area, that one, and what? And that one. Okay, so notice it's a rough estimation because we're losing this part here, that part, this whole area right here. Okay, and also this part right here. Okay, so it's basically finding the area of 4 rectangles. This is, pretty easy. Let me label these out as area 1, area 2, area 3, area what? 4. Okay, so the total area will be the sum of area 1, area 2, area 3, and area 4. Okay, area 1, how do we get that? Well, it's just the base, which is 2. 2 times the height at x equals 2, which is 1. So this is going to be 2 times 1. Here, it's going to be 2 times this height, which is 2. So 2 times 2. Okay, I'm going to just write these out. And then this one, again, the width is 2, but the height right here is -2. So this is going to be 2 times -2. And again, anytime you have an area underneath the curve, I'm sorry, underneath the x-axis, you have a negative area. So you have to make sure that this becomes negative. And this one's going to be positive, 2 times 1. So it's going to be what? 2. And so it's just a matter of adding these up. So we got 2 plus 4 minus 4 plus 2. Those would cancel out. And the answer is what? Answer is 4. Okay. All right. So we've covered the first one, the right endpoints. Now we're going to look at the left endpoints. I cropped another one here. Left endpoints, we're going to use the left upper corner of the rectangle. So again, if I do our intervals like this, I'll just kind of alternate color. This one didn't alternate. So, okay, so left corner will look like this, here to here. Okay, so just basically find the left corner, touch it on the graph, and just go straight across. Okay, it doesn't matter what the curve even looks like. This one, the left corner is going to start at 2, so it'll start right there. It'll look like this, straight across. And then at 4, the left corner is going to start up here, straight across your width. And this one, the left corner will actually start down here, right? So it'll be like this. All right, so it'll be this one, this one, this one, and what? This one. So again, area 1, 2, 3, and 4. Okay, so area total is equal to, the first area is 2 times 2, which is 4. And then 2 times 1, excuse me, is 2. And then 2 times 2, that's 4. And then 2 times -2 for the last one. Okay, now I've got the hiccups. I don't know why. 4 plus 2 is 6. 6 plus 4 is 10 minus 4, which is what? Which is 6. Okay, so that's another rough estimation of that. Now, the middle one is the worst, okay? Because you're not going to be using the left corner or the right corner. But again, if you split this up into its proper intervals, like this. Now, let's kind of think about this for a moment. Each of the of this width will contain a rectangle. Okay, so if I draw just a random rectangle, it'll look like that. But now what you want is neither the left corner or the right corner. You want the middle, excuse me, touching the graph. Okay, so here the middle will be at 3, so it's going to touch the graph right there. And what you do is again, you just draw straight across and come down and draw your rectangle. So between 5 and 6, where's your center? Is at 5. Where does it touch the graph? Right here. So that is going to look like this. Okay. And then the last one, the middle is 7. So you have to come down and touch the graph at 7, which is right here. And I'll just use a different color on that one. Okay. So it'll be here, 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 here. Okay. So area 1. Let me see. Area total. Okay. So area 1 would be 2 times 3, which is 6. And then 2 times 2, which is 4. 2 times 1, and then 2 times -1. So the area for this one is 6 plus 4, which is 10 plus 2, which is 12, minus 2, which is what? Which is 10. Okay. All right. So that's how you use a Riemann sum strategy procedure, excuse me, for left corner, right corner, and the middle.